again minus. So the value will be what here? Minus. I'm not multiplying data. It's not I'm multiplying. It is just I'm adding this minus plus minus. How much it will be? Minus only. That means delta G always will be negative. So whenever delta H is negative, understood better? Whenever delta H is negative, delta S is positive. That means exothermic reaction with increasing of entropy at any temperature, whatever the temperature it may be, delta G will be negative. Definitely that will be spontaneous. Correct. So in these two cases, always it will be spontaneous only. Next condition, let me see. Delta H is negative, delta S also negative. Now let me take what will be the delta G values here. Again, I'm just roughing this one, putting this values over here. Now, delta H is negative, minus T into delta S also what? Negative. Now here, this is a multiplication beta. Everything is multiplication. Okay. Others are. Now, negative minus into minus, how much beta? Minus into minus, multiplication it is. Minus into minus plus. So I can write here positive. I'm writing here positive. Now, the delta G will be negative or positive? Tell me beta.
Negative, sir.
Negative.
How do you say delta is negative? For example, if it is minus 2, if it is what happened? Plus 4. Delta G will be how much it is? Positive or negative?
Positive.
Positive. So it depends upon what temperature. Why? Because you have temperature. T still is there. T is there. Now at high temperatures, okay? At high temperature, if temperature is what high? High elevated temperatures, very high temperatures, this positive value will be more. Correct? At low temperature, negative value will be more. Correct or not? What I'm saying here, again I'm writing negative, positive into temperature. Now this temperature, if it is low, then this value will be more. Now based upon this, what can I say better? At high temperature, whenever delta H is negative, exothermic reaction, and entropy is decreasing, delta S is negative. In that case, the delta G will be negative at low temperature and delta G will be positive at high temperature. So at high temperature, understood better, at high temperature, this process will be what? Non-spontaneous. At low temperature, the process will be spontaneous. Do you understand this one?
Yes, sir.
At low temperature, definitely it is spontaneous. At high temperature, it is non-spontaneous. If you practice without substituting like this, definitely you will forget everything. Even you don't understand also what is this low, what is this high. Very simple beta. Again, I am revising. Please, all of you listen carefully beta. I have got negative for delta H and I got negative for delta S. But minus into minus, I got positive value. Now, if you have high temperature, if you maintain very high temperatures, then the positive value will be more. Delta G becomes positive. If delta G is positive, definitely that will be non-spontaneous. You see what happened at high temperature, isn't it? At high temperature, this one at high temperature, delta G got what? Positive, non-spontaneous, right? Non-spontaneous. At low temperature, this value will be low and this value will be more here. Negative value will be more here. In that case, delta G will be negative. When delta G negative means what happens? Spontaneous. It is spontaneous. So remember this one beta. Next we will see what? Delta H is positive. Delta S is positive. Both are positive here. That means it is endothermic reaction. Here entropy is what? Increasing here. Right? Next. What will be the delta G? Again, I will substitute this one in this case. We substitute this one. If you get any doubt, you substitute like that. But in examination, if they ask what happened, you substitute. Don't by heart this one. Now put one positive over here. Delta H is positive like this. Minus T into. Delta is also what? Positive. Now positive. Now minus into plus, how much better? Minus into positive is how much better?
Minus, sir.
Minus only. So you are getting what? Here also same thing is you have to consider temperature. You have to consider temperature is what more? If temperature is more, T is more here. Temperature is high temperature. I'm writing not more. I'm writing high temperature. At high temperature, temperature is high. Definitely negative will be more here. This will be more. This will be more actually. So delta G becomes negative. At high temperature, negative, that means it will be spontaneous. At high temperature, it will be spontaneous. But at low temperature, same thing I'm writing, positive minus negative. Now temperature is what? Low here. If this value is low, definitely this value will be more here. Now delta G becomes here what happened? Positive. When delta G is positive, what we have to say beta? Non-spontaneous. So what I can write, at low temperature, this process will be non-spontaneous. Whenever if you consider endothermic reaction in which entropy is increasing, at low temperature, this process is what? Non-spontaneous process. And again, for endothermic reaction, delta H is positive, delta S is increasing. Then at high temperature, definitely delta G value are getting what? Negative. The reaction will be spontaneous at high. And lastly, when you observe, if delta H is positive, endothermic, entropy is decreasing, definitely delta G will be positive only positive. Why? Let me see this one again. Again, you substitute the values beta. Delta H, what will be? Positive. Next, T into delta is negative. So negative into negative, definitely what happened? Positive. Positive, we get only positive only. So at any temperature, if you take, at all temperatures, delta G will be positive and non-spontaneous. So in examination, 99% you may get a question from this in the MCQC. Follow this formula here, you will get the answer. Right? When you are following this one also, you just multiplication is important over here. Here you have to multiplication and here you have to add everything. These two things you have to remember. I think understood everyone. Any doubts you're having, you can ask me in a bit. Do you have any doubts?
No, sir.
No, sir.
The term low temperature, you are using high temperature in this one, they are relative. But a particular temperature could even mean room temperature also. The temperature mean even room temperature also. But tell me the answer beta. Yesterday we discussed this one. Gibbs energy is which type of function beta?
State.
Observe here beta. I have written, you observe this one. I have written delta G. Wherever you write delta beta, wherever you write delta, that is state functions only. They are what? State functions only. Remember this one. You write delta means a state function. They depend upon initial and the final states only. What is the relation between delta G and delta S? Can you give which is the corrective relationship? Delta G and delta S relationship, if you observe.
So C.
Delta G. Last class only we got this one. You observe this one. Last class we got this equation. Last slide also. In the last class, this is the last slide. Let me take this one. Last one. Relation between the delta G equilibrium constant K, delta G, and third law of thermodynamics here. Let me see this one here. Relation between delta G equilibrium constant. First of all, I have taken an equilibrium reaction beta. A plus B gives rise to C plus D. Forward reaction is there, backward reaction is there. This is the forward, this one is the backward. These are the stoichiometric coefficients, okay, of this equation. Number of moles also we can call theoretically. Okay, stoichiometric coefficients like that. Now Q I am writing here. Quotient is nothing but concentration of the products by concentration of reactant. Q is nothing but what beta? We are writing the concentration of the products by concentration of reactant. Now see the beta QC. Concentration of this reaction. Constant first products we have to write. Concentration of the C to the power of how many moles that were? C moles. Stoichiometric coefficient we have to take. Concentration of D. How many? What is the stoichiometric coefficient? D. Divided by concentration of products. What are products? A plus B are products here. Concentration of A to the power of A. This one. Concentration of B to the power of B. This A, B, C, D are constant stoichiometric coefficients. Can be called number of moles also. Theoretically, we can call number of moles also. For the gaseous molecules, if they are gases beta, gases do have concentration, no. So you have to take pressure, you have to take. In terms of concentration, you have to take pressure. If it is aqueous solution, if they are aqueous solution, you have to take this formula beta. Concentration, you have to take. Which formula? This formula, concentration. If these are about gas molecules, everything is gas here. If they are gas molecules, like this, gas molecule like this. Then take partial pressure of C. In terms of what concentration, take partial pressure of C. How many moles are there? C. Partial pressure of D, stoichiometric coefficient D. Partial pressure of reactants A. Partial pressure of reactant B. And there's stoichiometric coefficients. So this is for aqueous solution. This is for what actually? Gaseous molecules, right? A reaction coefficient Q will be similar to just like equilibrium constant. What is difference between equilibrium constant and reaction coefficient is this at any concentration beta, at particular concentration, at the middle of the reaction. So the reaction is taking place beta. At any point, if you write dissociation constant, that will be Q. After completion, if you write that one as a K, you can write. Both are will be same formula. Now, what we can write? Q is equal to K beta. I can write Q and K both are same. If what happens, if the equilibrium is established, both will be same only, right? A reactant products are in standard state. What is the meaning of standard state beta? The temperature is 298 Kelvin.
29.
1 bar.
1 bar.
Okay, whenever the temperature and pressure is there. Okay. Now delta G. What we write? Delta G formula. The Gibbs energy can be written like this. This formula we can write. This is the formula we can use. So all of you remember this formula. Only derivation. You can write like this. Now this is what? Q is equal to what beta? K, no? Now substitute in the place of Q. Substitute what happened? K now here. Now what we get here? This formula. See, delta is Gibbs free energy. What is delta G naught? This is at any temperature. Any temperature or given temperature and pressure. But this one will be beta at 25 degrees Celsius or 298 Kelvin temperature and what happened? 1 bar pressure. Then it is called standard Gibbs free energy. R is a gas constant. If you take a liter atmosphere 0.0821, bar 0.0831, joules 8.314, calories 2 calories. Same for temperature, Q for what happened? Reaction quotient, nothing but concentration of products by concentrations of reactant. Now at equilibrium, I told you no, delta G equal to 0. Correct or not, beta? At equilibrium, delta G equal to 0 or not? Last slides if you have. At equilibrium, delta G is equal to 0 or not? Last slides we have discussed this one, just know. Correct or not? Yes or not?
Yes, sir.
At equilibrium,
Yes, sir.
delta G equal to 0. If delta
Yes,
is greater
sir.
than 0, delta G is greater than 0, delta G positive, non-spontaneous reaction. If delta G is less than 0, delta G is equal to negative value or less than 0, it's a spontaneous process. If delta G equal to 0, equilibrium, delta G equal to 0. Now substitute 0 over there. And you take at equilibrium, I told you no, Q is equal to K. For example, a reaction is proceeding like this beta. Reactant is converting into product. At any point, isn't it? You are taking coefficient Q actually. But at equilibrium, this Q now becomes actually what? K. Now put everything into this formula. What we get? Delta G 0. Delta G plus RT into ln K. Now what we can write? Delta G naught is equal to minus RT ln K. Now what is ln beta? Ln is equal to, I told you, what is that? 2.303 into log. Correct or not? Substitute in the place of ln what? 2.303. ln is natural log. Natural log always is equal to 2.303 into log. Now substitute that one also here. In the place of ln, substitute what here? 2.303 log 10. That means log with respect to base 10 actually. Now we are going to get this formula. Minus 2.303 RT into log 10. This formula is useful for you for calculating the K value and delta G naught value. So this is called the relationship between Gibbs energy and equilibrium constant. Gibbs energy, standard Gibbs energy and equilibrium constant. This is the relationship. Very important formula this one. Delta G is equal to minus 2.303 into RT log K. Right? Here, very important thing if you observe here, if K is less than 1 beta, for example, this value is less than 1, means negative value, beta. Less than 1 is nothing but K is what? Negative value. Just imagine that. Now, what will be the delta G naught beta? Anybody? Delta G naught becomes what? Positive or negative?
Positive.
Positive here. Now it will be what? Non-spontaneous. Delta G is greater than 0 is nothing but delta G is positive. So it becomes here non-spontaneous. Next, if K is greater than 1, if K is got greater than 1, then K will be positive. Okay? K will be positive. Then delta G becomes beta. Negative. Delta G becomes here what happened? Less than 0 is nothing but negative. It becomes here spontaneous. So based on this, what we can write here, whenever K is what? Less than 1, the reaction will be non-spontaneous. K is greater than 1, the reaction is spontaneous. Now let me see one simple thing I will explain better. K is equal to what beta? Concentration of products by concentration of reactant. Correct or not? Tell me better. Yes or no? This formula is correct or not? K is equal to concentration of products by concentration of reactant. Say yes or no. Yes. Prathamesh? Are you there? Prathamesh?
Yes, sir.
This is correct or not beta?
Sir, I am not remembering. Sorry, sir.
What remembering? Just now I told you. Just now we discussed only no. I know everyone, 90% what happened, they will switch on their mobile and they will round in that home only. Or sitting in the bedroom, something like that. Otherwise, what happened? Doing some other things in the mobile. Just now I told you this one. Vaishnavi N or Vaishnavi J. This formula is correct or not beta? Shishidhar?
Yes, sir.
It's correct or not beta?
Yes, sir.
It is correct only. So Vaishnavi J, Vaishnavi N, they are absent. I will put mark absent only. Who are not responding, I will put absent. Even if you give wrong answer also, you are present only, because I need response. I don't need correct and wrong answers. I want what response from you. You don't respond anything, whatever. Understood? Even if you give wrong answer also, no problem. You are present only. But then why I am asking question, what happened? Whether you are interacting or not. Are you listening or not? For that reason, I am asking questions to you. You have to reply to me, whether it, whatever it may be. He said, what happened? I didn't listen, sir. He said something. Prathamesh.
Yes, sir.
If you observe beta, when you get greater than 1 beta, in which condition you will get greater than 1? If concentration of products are greater than concentration of reactant. Correct or not?
Yes, sir.
Now, when you get K less than 1, concentration of products are less than concentration of reactant. When you get K is equal to 1, if concentration of products is equal to concentration of reactant. Right? Now here, if you observe, in this case, K is equal to 1. This is at equilibrium beta. Generally, if it is equilibrium, whenever products and concentration reactants are equal, then it is equilibrium beta. It is an equilibrium. Now, when you have products concentration is less, reactant concentration is less, more. Which direction the reaction is taking place beta? Forward direction or backward direction? When you have more reactant concentration, reaction is proceeding forward or backward?
So forward.
This concentration is more beta. Now tell me, the reaction towards forward or backward? So less than 1, non-spontaneous reaction is what? Backward. Greater than 1 means what? Product concentration is more. This concentration is more. That means reaction is moving towards what? Forward direction. So reaction moving forward direction means what? Spontaneous process. It is in spontaneous. So we can write even K is equal to 1. What we get better? Delta G is equal to 0. It is in equilibrium. So all these are what? Very important for what? MCQ questions, 1 mark questions, objective questions. You will get this type of things, which are very simple for you. If you know this concept, it will be simple for you. Understood? Any doubts? If you want to ask, you can ask me better.
Understood, sir.
No doubts?
No, sir.
No doubt.
Right. This is the third law of thermodynamics. Nernst heat theorem also we can call. Nernst heat theorem we can call, or simply don't leave it this Nernst heat theorem because it is not there in the syllabus. Leave it this. Third law of thermodynamics. First law we completed. Second law we completed. Third law. What is this third law? The entropy of pure and perfectly crystalline substance is 0 at absolute 0 temperature. What I am writing here? Entropy is 0. Entropy is 0. The entropy got absolutely what? 0 it is. At what temperature? Absolutely 0 temperature. Now tell me what is absolute 0 temperature? Which temperature can be called absolute 0 temperature? Which temperature is called absolute 0 temperature? Better.
So 0 Kelvin.
Minus 273 is equal to what? 0 Kelvin temperature, right? Very good, better. Minus 273 degrees Celsius and 0 Kelvin temperature is called absolute 0 temperature, we can call. Absolute 0 Kelvin temperature is called absolute 0 temperature. At this temperature, the entropy of any substance, if you observe, which is in crystalline form, solid form, always will be 0 only. It will not have any entropy, 0 entropy. Now, what is entropy? Anybody? What is entropy?
Randomness.
Degree of randomness, better. Degree of randomness. Now, at absolute temperature, there is no randomness. There is no random. Degree of randomness is 0 here. Degree of randomness is 0 means what happened? Everything perfectly what happened? Order. Perfectly ordered. It is perfectly ordered here. Means it is in perfectly crystalline substance. A solid substance. So this is called what? Third law of thermodynamics. So at this temperature, gases will not exist here. No gas will exist this temperature. There is no disorder at this temperature. Right now, therefore what happened? There will not be water. No gases present at minus 273 degrees Celsius. But you cannot observe this one on earth condition. Minus 273 degrees Celsius is difficult to what produce here. We can produce up to minus 78 like that. But maintaining this temperature in the laboratory is very difficult for us because everything will become what? Solid now. That is the reason. This is called what actually? Third law of thermodynamics is very important. 1 mark question. You can put a star mark for this one for 1 mark question. State third law of thermodynamics like that. Now S is equal to 0 at temperature is equal to 0 because temperature how much taken by time? 0 Kelvin. Correct or not? How much temperature I have taken? Because temperature you have to substitute in terms of Kelvin only. Whenever you're substituting in the problems, the temperature must be in Kelvin. Temperature is 0. Entropy also will be 0. Now, I think you give answer for this one? Which is the correct answer, beta? Which is the correct answer in this one? Relation between delta G and delta K and K. Delta G.
D.
Delta G naught is equal to minus 2. It is correct only, but you can't take this value. If you don't take, this will be correct. Beta. This one will be correct. Correct or not? Understood? Now, what is the correct answer, beta? The entropy of perfectly
0.
always will be 0. According to thermodynamics. So with this, what happened? The theory part we completed. Theory part of thermodynamics is completed.
0.
And we'll discuss some problems here. 1-2 problems we'll discuss. Only one. You have a class at 10 o'clock now, I think.
No, sir.
No class today. For bio also.
Bio we have at 11.
11. Okay, no problem. I will finish at 10 only. You don't
Sir, D.
10, by 10 only I will finish. Right. So we have completed first law, second law, third law. Do you know about zeroth law? Zeroth law, you know? Do you know about zeroth law?
Yes, sir.
No problem. A when it is equilibrium with B and B is equilibrium with C, right? Then A and equilibrium with C. This is called what? Zeroth law. When A is equilibrium with B, B is equilibrium with C, then A will equilibrium with what actually? C actually. For example, in your class, I am taking 3 students here. Prathamesh is taking. Prathamesh. Okay. Next, what happened? Shashidhar I have taken. And I have taken something. Ayush I have taken. Now, Prathamesh and Shashidhar both are friends. They are very good friends. And Shashidhar and Ayush, they are also what? They are also friends. Okay. Shashidhar and Ayush are friends. Prathamesh and Shashidhar are friends. Now, because of this, what happened? Prathamesh and Ayush both become friends. Understood better? This is called what? Zeroth law. When A is equilibrium with B, B is equilibrium with C, then A is equilibrium with C actually. This is an example like that. Now, which is best application part for the zeroth law? Are you using this zeroth law in which type of application we are using? Tell me better, which application we are using in this? Anybody knows? Gulabi? Gulabi is there?
Yes, sir.
Do you have? Do you know any application better? The zeroth law? Thermometer better. Thermometer. So when you suffer with fever, whenever you suffer with thermometer, right? Better. When you suffer with fever, what happened? So how do you know the temperature of your body? By using thermometer. Nowadays we are using that different one. IR radiation we are using, no, because of the COVID, what happened? They are using what? Some IR things. That is different. But thermometer, if you observe, thermometer is the best example for zeroth law. How? Let me see here. Now you see, human being is equilibrium with what here? Atmosphere, environment, atmosphere. Right? Thermometer also with thermometer also equilibrium with what? Atmosphere. In that case, isn't it? This human being and thermometer will be in equilibrium. So this, based upon this concept, what happened? We can measure the temperature of body. This is about the zeroth law. Zeroth law, first law, second law, third law, isn't it? Zeroth law is not there in the syllabus. You can leave it there. But let me see some problems today. You can ask me now. Start now what happened, some problems over the thermodynamics, whatever the problems are there. How many are there? 54 only. 7 members were absent today. Enthalpy of formation problems are important. We'll do that problems also. Is it possible for you, beta? These problems are solved problems. You try these problems. Wherever if you get doubt, you can ask me here. These problems. Wherever if you get any doubts, because they are solved problems. Based upon this, we can do this one. So if you have any doubts, you can ask me here. Later also you can ask me. Whichever the solved problems are there, you can easily ask me. You try these solved problems better today. All of you try whatever the solved problems are there in the pink box. Okay. This box, whatever they given, you solve this one. If you get any doubts, tomorrow we'll discuss that one. We'll do now exercise problems now. Molar heat capacity is not there in the syllabus. Leave it this 6.9 better. 6.9 is not there in this. So we'll do from last onwards. So that what happened will be easy. Because first problems we have done some problems. No? Now let me take this 6.22 better. We'll do 6.22 now. Calculate the entropy change in the surroundings. They're asking better, calculate the entropy change in the surroundings. When 1 mole of water in liquid state is formed under standard conditions, given enthalpy of formation, enthalpy of fusion is given 286 kilojoules. Now what they are asking here? Entropy change, delta S they are asking better. Delta S formula can bet anybody? What is the formula for entropy formula? Q reversible, that means surrounding you can take, or reversible, whatever, surrounding I am taking. Because in the last class we discussed Q surrounding, or Q by, simply leave it this one. To avoid the confusion, what happened? Q by temperature, correct or not better?
Yes, sir.
Heat by temperature is called nothing but entropy, correct or not? Now, whether temperature is given or not, tell me better. T is given or not?
Yes, sir.
Standard conditions. Temperature will be 298.15 Kelvin temperature. Okay, right. This one. Heat is how much given there? Because this is what is the question actually? Calculate the entropy change in surroundings when 1 mole of water is formed under standard conditions. 1 mole of liquid is formed. Now, let me take liquid. How will form beta? Ice will convert into water. This is H2O liquid. This one is H2O solid. Now, this process is called what? Fusion or freezing. Which process we call beta? Enthalpy of what we call beta?
Fusion.
Fusion we can call. This process is called. How much they taken? 1 mole they take. If they taken 1 mole, what happened? Enthalpy of fusion means the amount of heat exchanges when 1 mole of a compound is undergoing melting or fusion. Then that is called enthalpy of fusion. How much they given enthalpy of fusion beta? Minus 286 kilojoules per mole is given. Minus 286 kilojoules is given. Right? So substitute this Q value. Q is nothing but what? Enthalpy in surrounding in this fusion. What is enthalpy of fusion? Delta H minus 28. Now substitute here minus 286 kilojoules per mole divided by temperature. Temperature is how much here? 298.15. Now you will get whatever X is the answer in terms of, isn't it? Now whether I have to take here minus or plus beta? I have to take minus or plus here? Because here minus is given, because exothermic process, minus is given here. What I have to take here? Anybody knows? Now in this case what happened? Heat lost to surroundings here. Delta here minus 286 is given, means what actually? In this process, minus, that means 286 kilojoules of heat which is lost to the surroundings, because in this process, negative process, no. So heat is given to what? Surroundings here. Correct? Now surrounding will gain or lose here beta?
Gain.
Surrounding
Sir,
is gaining. So when surrounding is gaining, Q will be positive or negative beta?
Positive, sir.
So they are asking for surroundings beta. They are asking surroundings because they are saying this process, conversion of what? Formation of water liquid form, formation of this water liquid form, they are saying what? 286 kilojoules of heat is liberated. This much amount of heat is liberated. Now surroundings will absorb this heat. Correct or not? Surrounding is absorbing the heat. Heat absorbing means what happened? I have taken plus 286 here. So surrounding is gaining here. So plus 2 here, because they're asking entropy change for surroundings, they're asking. Therefore, Q surrounding by temperature. So plus 286 by 2 net. This is for kilojoules beta. If I want to get in joules, what you have to take? Plus 286 into, isn't it, 10 to the power of 3 joules per mole I will get. Divided by 298.15 Kelvin temperature. So you are going to get in terms of joules, kilojoules, you can get in terms of joules also. This is the 6.22. Understood beta? Next we'll take 6.291, beta. 6.21, let me discuss about 6.21 now here. They're asking a comment on the thermodynamic stability of a nitric oxide. That means whether spontaneous or non-spontaneous they're asking. Now we have to see spontaneous based on the delta H values only. Based on delta H values only, we have to see this. Because the given values are delta H only. Now, for example, for nitric oxide, this one, for the formation of nitric oxide, delta H is positive or negative beta? For the formation of nitrogen dioxide, delta H is negative or positive? Yes? Are you there?
Negative, sir.
Right. Now, generally, leave it because your entropy is not. Also, you don't know that one. Only based on what happened? Delta H values. So, always remember, generally I told you, exothermic process, delta H is negative, exothermic process generally happens here. Generally they are what? Spontaneous. Generally they are spontaneous. Conversion of ice into water, spontaneous, because here you see, minus or you got, spontaneous you got. So based upon this, what happened? What we can say beta? Which is stable? Nitric oxide or nitrogen dioxide? Which is stable beta? NO or NO2? Which is stable beta?
NO2.
NO2 is stable, very good, because it is spontaneous beta. You can also explain like this also beta. When you have some heat within you, you are unstable beta. Whenever system lose heat, it becomes stable, correct or not? Because of the heat only it's unstable. System is having certain amount of heat in that one. So when it lose that heat, what happened? It will become stable. How it lose? In exothermic process. Whatever excess amount of energy released here, it is released everything. So it becomes stable now here. So answer will be NO2 only, right? We'll do say last problem beta 6.20 will do. After that, what happened? We can 6.20. So that 191 page will complete. Equilibrium constant for a reaction is 10 they given beta. Equilibrium constant, how much they given? 10. Let me discuss again this one. Simple problem. First of all, we'll write the formula for anybody. Tell me the problem for the formula for delta G naught formula. Tell me beta. Delta G naught is equal. What is the formula? Anybody? Just now we discussed this one. Minus 2.303 into RT into log K. Now let me substitute here temperature. How much it is? 300. Next R value. How much it is? 8.31. 8.31. Next equilibrium constant. K is given 10. Not log K beta. K is given 10. Right. Now delta G naught will be how much here? Delta G naught is equal to 2.303 minus 2.303 into 8.314 R value it is. Next temperature 300 into log 10. Log 10 is equal to, do you know anybody? Log 10 is equal to how much beta? What is the value of log 10? Anybody?
1.
1. Log 10 is equal to 1 beta. So multiply everything, you will get the answer here. Okay, you multiply everything, you will get the delta G naught value. So very simple problems only you will get in examination. So you have to remember what formulas. So today what is your homework beta? Today Monday what you have to do? Today you solve whatever solved problems, try to solve everything, whatever the solved problems. And write all the formulas in one page. Formulas, whatever formulas, for example, W is equal to minus P delta V. Okay. Work done in the reversible process, minus 2.303 into what? RT into log V final minus V initial like that. Delta S equal to Q reversible by temperature like that. Delta G is equal to delta H minus T into delta S. Like that you write all the formulas in one page so that whenever you go to examination, you can read that all formulas easy for you. So this is the homework today. Understood?
Yes.
Right. We'll take attendance now, beta. You stay with me 1 minute. I will take attendance now. Abhishek Sharma is absent today. Abhishek Sharma. Absent Abhishek Sharma. Abhishek, why?
Present, sir.
Aditya,
Present, sir.
Akriti,
Present, sir.
Anshu Yadav, Anuj,
Present, sir.
Present,
Anushka,
sir. Present, sir.
Ashif, Atharva,
Present,
Atul
sir.
Rawat,
Present, sir.
Ayush,
Present, sir.
Balmukun,
Present, sir.
Chaitanya,
Present, sir.
Manusri,
Present, sir.
Deepta,
Present, sir.
Jnaneshwari,
Present, sir.
Gulabi,
Present, sir.
Kalpesh,
Present, sir.
Kaushal,
Yes, sir.
Krunal,
Present, sir.
Mayur,
Present, sir.
Manoj absent. Manoj is there? Right. Ojas,
Present, sir.
Omkar M,
Present, sir.
Omkar C,
Present, sir.
Pallavi,
Present, sir.
Samiksha,
Present, sir.
Pradhamesh,
Present, sir.
Raghav,
Present, sir.
Rahul,
Present, sir.
Raj,
Present, sir.
Ramya,
Present, sir.
Riya,
Present, sir.
Rohit,
Present, sir.
Sahil, Samruddhi,
Present, sir.
Sapna, Sardak,
Present, sir.
Shashidhar, Sri,
Present, sir. Present, sir.
Present,
Sneha
sir.
ji,
Present, sir.
Sneha VS,
Present, sir.
Sonali,
Present, sir.
Sumit M,
Present, sir.
Sumit D,
Present, sir.
Suraj C,
Present, sir.
Suraj U,
Present, sir.
Triambak, absent. Triambak is there. Swastika,
Present, sir.
Tejaswini,
Present, sir.
Vaishnavi J,
Present, sir.
N,
Present, sir.
Vaman, Vedant, Vishal,
Present, sir.
Yes.
Present, sir.
Just I'm reading the absentees names, beta. Bharati, Bharati is there.
Present, sir.
आपका नाम नहीं आ रहा उसका. उमेश, absent. Umesh, Umesh absent. Triambak absent. Manoj absent. Apurva absent. Apurva absent. These are the absentees today, beta. Now, just a minute, beta. Few seconds about the art integration.